Good evening, everybody, and welcome. My name is Dr. Katerina Richter. I am an NHMRC Early Career Fellow at the University of Adelaide School of Medicine, and I'm delighted to be your host of tonight's 3-minute thesis final. I would first like to acknowledge the Kaurna people, the original custodians of the Adelaide Plains, and the land on which the University of Adelaide's campuses at North Terrace, Wade, and Roseworthy are built. I'm delighted to welcome you all over here in the audience and online on our Facebook live stream. Also, a special welcome to students from Brighton Secondary School who are joining in for tonight's 3-minute thesis event. 3-minute thesis is a national competition which sees PhD students compress the journey of their project, years of research and hard work, cluelessness and epiphanies into just 3 minutes. We are all excited to listen to 10 fantastic stories tonight. The 3-minute thesis concept was developed by the University of Queensland in 2008, and since then it has been adopted by over 600 universities across 59 countries. It's become an important event in the Research Tuesday series, as we love to showcase the great work of our early career researchers. This event also provides the perfect opportunity for our PhD students to own their communication skills and to share their research with the general public. With a 3-minute thesis, we are part of a worldwide wave of change in academia. Science communication has become an instrumental tool to bridge the gap between science and society, providing a stronger understanding of research and its real-life impact. For the new generation of researchers, science communication is an essential skill to learn, and the 3-minute thesis is an excellent opportunity to start. Dozens of PhD students from the entire university have been vying for a special place at tonight's final, and soon we are going to hear from the top 10 storytellers of 5 faculties. Now, I know exactly how the finalists are all feeling right now, because I too participated in this competition 2 years ago. Having been through the roller coaster of a PhD, the ups and downs of research myself, I know how challenging it is to survive as a student. And then they push you out there, out of your comfort zone, and, well, make you, or, well, they use a nice word, they encourage you to do science communication and public speaking. You need to be brave to put yourself out there, but you can gain so much. A quote says, "Bravery is the capacity to perform properly, even when scared half to death." Trust me, this is exactly how I feel still today before public speaking. I'm typically a nervous wreck and very fidgety, so my secret to success is I find a remote corner and jump to shake off my nervousness, and then I pretend that this is not embarrassing at all and that I'm cool on stage. This strategy worked for me, and it made me win the People's Choice Award 2 years ago. So be brave, take risks, and get yourself out there. Nothing can substitute experience, and you can be so proud of yourself. This is your platform to promote yourself and make you visible and create opportunities for your future career. So allow me to give you all some final advice. Breathe, focus, and smile. Don't worry if you stumble, nobody's perfect, we're all just humans. But the show must go on. Invite us on a journey into your research and inspire us with your personal story. Tonight's 3-minute thesis winner will compete at the Asia Pacific Finals, which will be held later on this month in Queensland. But before we begin, I'd like to invite our Pro-Vice Chancellor, Research Operations and Dean of Graduate Studies, Professor John Williams, to say a few words.
Colleagues and friends, thank you, Katerina. And I just should say that this year, just to give you the flavour of it, at the 2018 Essay Science Awards for PhD in Excellence, Katerina won the category of all the PhDs in South Australia. So could we give her a hand on that? So I'd like to welcome everybody here to this very special Research Tuesday event. and I'd like to pay my respects to the Kaurna people upon which the university is founded. Each month, the Research Tuesday leading researchers from the University of Adelaide discuss some of their groundbreaking research. This series helps us to illustrate the diversity and the quality of the research undertaken here at the university. But tonight's focus, as you heard, is on our young researchers, our PhD students, who you will see are all stars. The three-minute thesis competition is all about communications. It's a key skill for our researchers, and I'm very pleased that our participants here today took the encouragement to participate. As a university, we both have the responsibility as well as the strong desire to share our knowledge and research outputs with the community. Ultimately, it's the social license for which we are here, taking our research to the community. And that's not always easy, especially when you're dealing with very technical and specialist topics. The 3-minute thesis competition allows our students to develop the skills in an enjoyable, and I underscore that, if not nerve-wracking way. Tonight you'll be privileged to hear from 10 of our young and very enthusiastic researchers who represent a variety of disciplines across all academic interests. Although only beginning their research, these students are conducting important work which will help advance the knowledge and benefit our society in so many ways. The aim of the 3-minute thesis is to ensure that we will know not only the quality of their research, but also the ability to communicate that knowledge and its significance for our wider community. Whether or not you win here tonight, the skills that each of the future researchers have gained through the 3MT competition will advantage you throughout your careers. They are all stars. So thank you again for being here, because you, the audience, are a very important part of the 3-minute thesis experience, and good luck to all our students. Thank you very much.
Thank you, John. Now, before we begin, I'll briefly talk through the competition rules, the judging criteria, and introduce our judges. There are some very simple but very challenging rules that our students must follow in this competition. Only a single static PowerPoint slide is permitted, no animations, no electronic media, no props, no poems, raps, or songs. Yeah. Presenters must stick to 3 minutes, otherwise they're disqualified. Basically, no nonsense, just you guys, 3 minutes, a static slide, and the stage. Now, the judges will score the presenters on comprehension and content, as well as engagement and communication. How well the background, the research question and its significance, the key results and conclusions were explained. If the presenter used a language appropriate to a non-specialist audience without relying on scientific jargon to illustrate points. How well the story flows, and if it makes the audience want to know more. If the presenter conveyed enthusiasm and captured the audience attention. How confident and persuasive the speaker communicated, and how well the PowerPoint slide enhanced the presentation. Our 10 finalists will be scored by a panel of 5 judges I'd like to introduce now. Judges, please stand as your name is announced. Dr. Richard Harvey please stand up. Thank you. Dr. Richard Harvey was elected as the member of Newland in the South Australian Parliament in March this year. He completed his undergraduate and postgraduate studies at the University of Adelaide, holds a PhD in microbiology, and worked as a medical research scientist before his election. Our second judge is Andy Keogh, who is the former Defence SA Chief and current Managing Director of the Defence and Security Company Saab Australia. Having served for 22 years in the Australian Navy and with a special interest in submarines, he is involved in the Subs in Schools program. This national high school competition allows students to explore maritime engineering and hydrodynamics as they design and build operational submarines, ultimately encouraging students to pursue a path in defense engineering. Another judge is Eliza Black, who is a medical research reporter at The Advertiser. In her spare time, Eliza likes to read about gory operations and the evolution of medicine. She would have made an excellent doctor, but rather chose to become a medical journalist to satisfy her thirst for blood. Just a week ago, she actually wrote a great article about my research with the title, "Scientists Slaying Superbugs." Now, guys, if you want to make the next catchy headline, make sure to talk to her. Perhaps invite her for a Bloody Mary. Our fourth judge is Professor Michael Webb, who is the Director of Defense and Security at the University of Adelaide. Following a master's in mathematical psychology, a PhD in physics, and 20 years experience in the Defense Science and Technology Group, Michael is now engaged in defense and security-related research and education. He currently supervises PhD projects on next radio networks and automation and coordination in social media behavior. Our fifth judge is Renee Hakendorf, who is the Innovation Hub Manager of ThinkLab, the university's new venture incubator. She supports the career and acceleration of startup companies, including those led by our students. With a background in marketing and research commercialization, Renee is passionate about supporting innovation in South Australia. Guys, if you ever get sick of academia, this is the lady to talk to. She can help you found your own company, which is a good thing to do. The judging panel will choose one winner to attend the Asia Pacific 3-minute thesis final in Queensland, and the winner will receive a $2,000 travel grant plus free travel and accommodation to Brisbane. Tonight, the audience is also given the opportunity to choose a winner with your vote for the People's Choice Award. On arrival, you should have received a voting form. If not, please see one of our staff. You can vote for your favorite presenter, and the winner of the People's Choice Award will receive a $1,000 travel grant. And this year, for the very first time, we have introduced the ThinkLab Best Pitch Prize. This prize is awarded to the finalist with the best presentation and is based on the performance only. The winner of this prize will be awarded by the manager of ThinkLab, Renee Hakendorf, and the prize is worth $500 to go towards private presentation coaching sessions to help further refine the winner's pitching skills. Now, some boring house rules. Please, the mobiles should be switched off or silent until the voting begins. Stay seated until the presenters have completed their 3 minutes. No flash photography during talks, and the toilets are actually located in the building behind me. So the best way to access them is just go up the stairs around the corner and just follow the signs. Now let's get started. I will introduce each finalist and they will give their 3-minute presentation, after which a judge will ask a question to seek feedback. Please save your applause until the finalist addressed this question. Following the final presentation, the judges will step away for 10 to 15 minutes to deliberate while the audience completes their votes for the People's Choice Award and hands their voting papers to the assistants. Finally, I will invite the finalists to stand and join me for the announcement of the winners in due course. So, the first presenter is Veronica Coram from the School of Social Sciences with a presentation entitled Future Benefits, Future Burdens.
Do you want to leave a better world for your children? A number of studies suggest that people born after around 1975 in Australia, the US and the UK are likely to be worse off across their lives than their parents. On average, they are likely to pay more tax, have fewer job opportunities, be less likely to own a home, and have to work well into their 70s whether they want to or not. Their lives are likely to be riskier and less comfortable. This is partly because the post-war economic boom was a one-off that has now come to an end, and our population is ageing. 40 years ago, for every senior, there were 7.3 workers. It will be down to 2.7 in another 40 years. Super isn't going to help much. The government estimates that seniors reliant on the pension will drop only slightly, from 70% to 67%. Only a third of people use their super mainly to support themselves in retirement. The rest take it as a lump sum, spend it or pay off debt, and then fall back on the pension. I wanted to know if people thought whether Australia's current tax and welfare policies were fair and sustainable into the future. I surveyed and interviewed a group of young adults and a group of seniors. My participants were concerned about inequality in Australian society. They thought that there were serious economic challenges ahead and the government should be doing a better job of planning for the future. However, participants had a strong belief in individual freedom and autonomy, which made them accepting and acquiescent to the status quo. It's common for people to believe that hard work equals success. My participants recognised that luck and being an insider who benefits from how the system works also have a lot to do with success. Yet they still felt that people were entitled to keep their gains, even if they hadn't exactly earned them. If you happened to be born in the right place, at the right time, or to benefit from particular government policies, good luck to you, bad luck for the rest. It would infringe on your individual rights too much to have to consider the collective interest. The young people believed this especially strongly. Australia is unlikely to have fairer or more sustainable policies moving forward unless young people in particular can be motivated to act together and demand policies based on the collective interest rather than on the individual interests of a few. This might be more likely if young people felt that Australian democracy offered greater opportunities for their voices to be heard. Thank you.
Would any of the judges please ask a question? Excuse me, the judges should ask a question.
Veronica, hi. Renee here from Think Lab. Thank you for the presentation. I wondered if you could have a bit of a stab at trying to quantify the impact of your research so far, or where you hope to take it in the future.
So I'm looking at people's attitudes towards a handful of specific policies. The best examples are probably some of the tax policies like superannuation tax concessions and policies that benefit homeowners, capital gains tax discounts and exemptions, negative gearing. Those are definitely areas where there's an argument that they're funneling resources towards certain groups in society and may well require tax hikes at some point, and the accumulation of public debt is another one. So I guess I would like to see some moves towards reviewing the impact of some of those policies on different groups in society.
Thank you, Veronica. Our next presenter is Joseph Rossi from the School of Biological Sciences with a presentation entitled Love, Betrayal and Cunning, a Biochemical Interaction Story.
All right, I'm going to tell you all a story of love, betrayal and cunning. So our story starts with two proteins, SIM1 and its partner ARNT2, who are so madly in love that they only function when they are together. And when they are together, they have a very important job to do in the brain, where they help control appetite by telling you you're full. And if you don't have a working SIM1 protein, you'll develop obesity because your brain never tells you that you're full and you just keep eating. But no matter how strong a power couple seems, they are never above a scandal and betrayal. So we noticed that this other protein, OTP, was in all the same places as SIM1. This was very suspicious. And looking a little bit further, we noticed that OTP also regulates appetite in a very similar way to SIM1. Now, OTP was thought to do this by itself, but we thought something more sinister was afoot. we thought that maybe Sim1 was cheating on ARNT2 with OTP, and that Sim1 and OTP had their own thing going on with appetite regulation. And in my initial experiments, I saw that Sim1 and OTP did interact. And you can think of this interaction as basically two proteins cuddling. So it appeared that Sim1 was seeing both ARNT2 and OTP in an appetite control love triangle. However, we needed to confirm this love triangle by using our cunning to catch Sim1 and OTP in the act. And to do this, we turned to the protein tracking system developed by Stephanie Cabantas and her colleagues, in which a green fluorescent protein is split up into 3 puzzle pieces, such that each piece is useless by itself, and only when you put the puzzle back together do you see green fluorescence. Now the clever part is in how you put the puzzle back together. So the 2 proteins you want to track each have 1 puzzle piece added to them, and the 3rd piece is allowed to move around freely. Now if the 2 proteins are nowhere near each other, the puzzle remains incomplete and you do not see fluorescence. However, if the 2 proteins are interacting or cuddling, like we think is happening for Sim1 and OTP, then the puzzle pieces attached to the protein are brought close enough together that the 3rd piece can join, completing the puzzle and giving green fluorescence. In my experiments so far, I have seen this green fluorescence between Sim1 and OTP, indicating that they are cuddling and that there may be a love triangle between Sim1, ARNT2, and OTP. So this is actually pretty cool because it's the first step in characterizing a potential new way for appetite to be controlled. And in the future, we could take advantage of this by designing drugs to alter the function of these proteins, allowing us to help people with eating disorders by controlling hunger. Thank you.
Thank you very much, Joseph. My name is Richard Harvey. We used to work in the same building. Question for you, how do you envisage some kind of medical intervention interfering in that interaction?
Yep, so there's really 2 ways that this could happen. So like I said at the beginning, when you knock down Sim1, you get an insatiable appetite, you just can't stop eating. So that wouldn't necessarily cure obesity, but there are individuals who suffer from a complete loss of appetite, especially in cancer. So in theory, a drug which could target these proteins could help someone with cancer regain their appetite, because we all know nutrients is essential. But also, on the flip side, if we can elucidate or discover the whole pathway around appetite control, we could discover a small molecule that is deficient in these people with overactive appetites. And then if we discover what that molecule is, we can give them that molecule back, and then in theory, their appetite should come back down. So there are really 2 ways to bring that into therapeutic use.
Thank you, Joseph. Our next presenter is Aditi Roy from the School of Economics with a presentation entitled Missing Women in Management.
Welcome to one of the leading job application portal in India. Over here, you can see various openings for the managerial position. And you may notice that one of the key eligibility is to meet the gender criteria. Surprise, right? Well, this is reality. Now imagine this happening in Australia. Although advertising jobs based on gender is not accepted in most of the developed countries, but is very much in practice for majority of the openings in India. And this is so because there is no Gender Act in place in the private sector. And this scenario left me thinking, does this have any impact on the success of the company? And motivated me to do my research on the impact of female management on company performance. So for my study, I utilized data set of more than 9,000 companies from World Bank Enterprise Survey, and I examined the impact of women management on the performance of the company at 3 levels. First, sales. Second, labor productivity. And third, exports. So by using advanced statistical techniques, what does my results reveal? My finding shows that when there is a woman in a managerial position, then it does have a significant and a positive impact on the success of the company. And on average, the performance of the company goes up by 5%. Despite this, only 7% of companies have women managers. Well, India is not only gender neutral, but gender blind towards their policies. And the contribution of my research is directed towards the policy makers of the nation to come up with more gender inclusive policies. Because as nation, we cannot think of economic development by taking one half along with us and leaving the other half behind. It's 21st century. And not a single country can claim that they have achieved gender equality yet. So today when you go home, remember, gender equality is your issue as well. And we are at a point, a crossroad, where we must actively contribute towards eradicating discrimination around the world. Because in the end, gender equality is not a zero-sum game, but a win-win. Thank you.
Thanks for that presentation. And it's interesting if there's a correlation between your analysis, which showed a 5% improvement, and some polling done in the seat of Wentworth, which shows a 4% improvement to the Liberal Party votes if they get a woman candidate that was released today as well. So maybe there's a correlation there, but maybe I'm stretching it. But great presentation. How do you think you can translate that observation of 5% improvement into actually making the difference? Because we have a narrative about the importance of diversity, but as you point to, it just doesn't seem to be cutting through. How do you think we can start that process?
Well, I reckon imposing quota system to begin with. And as we know, some policies look good on paper, but is irregular on implementation. So first we can go for a quota system and then analyze how is it going, and then we can accompany it with other policies to complement it. Thank you.
Thank you, Aditi. The next presenter is Sarah Bernhardt from the Adelaide Medical School with a presentation entitled That Time of the Month When Menstrual Cycle Stage Affects Breast Cancer Treatment.
Meet Bethany, a 44-year-old mother diagnosed with breast cancer. Now she, with her doctor, has to decide on how to best treat her cancer. Like many other women, Bethany has a hormone-responsive tumour. This means that hormones help her tumour to grow and survive. For women with tumours like this, it can be challenging for their doctor to determine if chemotherapy is necessary, because some of these tumours can be treated with chemo, while others can't. Now becoming available are new tests which diagnose breast cancer by looking at how a cancer behaves. These tests help doctors make decisions about chemotherapy that may otherwise be difficult. Bethany, guided by her doctor, turned to these tests and was informed that she would benefit from chemotherapy. Bethany decided to proceed with a 6-month course of chemo. But Bethany is a premenopausal woman. These tests were developed in postmenopausal women. This is a problem. Premenopausal women have menstrual cycles. Postmenopausal women do not. In premenopausal women, there are dramatic fluctuations in hormone levels of estrogen and progesterone during the menstrual cycle. In postmenopausal women, there are not. And so, what does this mean? Has Bethany and her doctor made the best treatment decision? My PhD answers this question, focusing on how changes in hormone levels during the menstrual cycle can affect breast cancer diagnosis and treatment recommendations. We have found that menstrual hormones can significantly influence how breast cancers behave. Using several different mouse models of breast cancer, we found that tumours diagnosed when levels of progesterone are high show a different diagnosis compared to tumours diagnosed when levels of progesterone are low. We are now taking this into the clinic using breast cancer samples from premenopausal women. Our results suggest that new tests may not be appropriate for use in premenopausal women. The breast cancer diagnosis and treatment that a woman receives may depend entirely on the day of her menstrual cycle. For Bethany, if she had been diagnosed just a week earlier or a week later, she may have received a different diagnosis. And this could mean the difference between a 6-month course of unnecessary chemotherapy and Bethany getting back to her life and her family that much faster. Thank you.
Hi, as a medical research reporter and a premenopausal woman, I'm curious to know how you now use this information to move forward in giving women the best treatment, and whether it's about tipping somebody into menopause or whether it's, and how it would change from month to month, because I understand those cycles can change monthly.
Yeah, so based on the mouse work that we've got, the hormone environment really sort of influences the diagnosis that you get. So whether it's possible to diagnose a woman at a particular time in her menstrual cycle, or whether we should just not use these tests in premenopausal women, whether they should be used exclusively for postmenopausal women with breast cancer.
Thank you, Sarah. Our next presenter is Caitlin Gray from the School of Mathematical Sciences. Her presentation is entitled Understanding Human Interaction in the Online World.
Everyone in this room is connected. Maybe you know the person sitting next to you, and they know the person next to them. Maybe your friend went to school with the lady up the back, and now you all know me. It's through these social connections that we talk and share information, from important things like the news of the day to trivial matters like the joke that we just heard. Now, of course, the way in which we communicate is constantly changing. We all remember posting letters to our friends and pen pals. Now, with the click of a button, I can contact anyone that I know. As a society, we have moved much of our life online, and communication platforms like Facebook, Twitter, even our email, are now just a part of our everyday lives. This whole new world of social media provides a previously unavailable window into how we all communicate. This is a whole new world where both people and ideas can be shared, promoted, and influenced. In my research, I use mathematical models to understand how humans interact in both the online and the offline world. We model the flow of an idea, maybe a photo or a meme, to understand how the underlying network structure, who's friends with whom, impacts information flow. Now, this is all a bit of fun if I say, model that funny cat video I saw the other day. But we can use these ideas to model behaviours that have real impact. The dissemination of propaganda in the American election has influenced the world as we know it. Understanding how these malicious sites structured themselves within our social network to influence so many people is imperative if we are to safeguard our future elections. Now, I'm a mathematician, but the answer to these questions is not 3.5 or even 42. We use mathematical models to develop an understanding of the underlying process. Because with understanding comes the ability to make real change. With this understanding, we can determine where and when we should intervene to prevent violent riots from breaking out. With this understanding, we can efficiently inform people of impending bushfire and hurricane threats. Everyone in this room is connected. Through understanding these connections, we can all contribute to making decisions that have a positive impact on our society. Thank you.
Thank you, Caitlin. I found that very compelling. That was fantastic, thanks. understanding leading to intervention. Have you come up with any thoughts about specific interventions that might make a real difference in the way social media plays these things out?
Yeah, so we focus on understanding in comparison to a computer science where they give you the answer. And so we look at how the structure, so is having someone with lots of friends more beneficial in promoting your product or to tell people about an impending bushfire? Should we be targeting those people, or should we be targeting a grassroots uptake? Because that's can be more efficient in some cases. So you find that if you have these highly connected people and you target them, that can be really good. But if you have them in your grassroots network, they can sometimes hinder the flow because they're a little bit too strong and don't see as many of these grassroots. Thanks.
Thank you, Caitlin. Our next presenter is Chidozie Alozie from the School of Education with a presentation entitled "The New Problem We All Live With."
Benjamin Franklin observed that there are two certainties we all live with: death and taxes. But there's a third: educational reform. Because the world seems locked in this continual process of the deconstruction, the reconstruction, the reformation of its educational systems, with policies emphasizing competition and testing as accountability, or what Diane Ravitch likes to call weighing the pig in order to fatten it, all for a prized position atop the global educational rankings. Now, in Australia, what began as alarm over a 44% increase in educational inequality due to socioeconomic status, and then resulted in the political contest over who gives a Gonski the most, has now become a conversation on inequality using such terms as white flight and racial segregation. Startling, but American terms. More unsettling, however, is that this Australian conversation should take place while the US faces its own crisis of resegregation within schooling, back to levels not seen since the 1950s. You gotta ask, is this just a coincidence, or is there something in the only concrete link between these two contexts, their policies of reform? Has this globalized reform imported American-style inequality into Australia? Is this the new problem we must all live with? So, my research examines educational reform policy in the US and Australia in search for patterns within policy which might indicate a relationship to this segregation, and also looking at how and why policy might manifest in specific ways. Some things I've found: policies in both countries place policy users, and especially parents, within a competitive arena where education becomes a search for individual advantage and a winner-take-all struggle. These policies also locate disadvantage within specific groups of people, thereby encouraging discriminatory perspectives through such mechanisms as school choice. Using these and other findings, I've developed a model to explain the relationship between reform policy and segregation, but also policy options to address this phenomena. Now, to be clear, educational reform does not create segregation, but it does create the conditions and the perspectives through which we will accept it. Because reforms don't just fix classrooms, they reform us too. Simply put, if we allow people to be educated separately, we run the risk of creating ghettos and hostile social attitudes, and with them the cycles of discontent which we witness in the US as a result of such inequality. James Baldwin wrote that people pay for what they do, but even more for what they will allow themselves to become. Segregation and desegregation are painful and ugly processes. Is this what we wish to become? Thank you.
A question from the judges?
I'm going to jump forward on that one. Thank you for the presentation. Can you tell us how has, and whether it has, your own personal experience, family experience shaped the nature of the research that you decided to undertake?
Yes. I've been lucky enough. I was born in Nigeria, raised in the States. I now live in Australia, in Clare. And I did, quite honestly, I grew up in the South Bronx. I saw what schools looked like, but I was lucky enough to get a scholarship to attend a private boys' school in New York City, in Manhattan, in the Upper West Side. And to be really specific, it was while doing my master's work, I saw a New York Times article about progressive enclaves in America suffering from white flight and segregation. The school they listed was PS 199. My school, I was bused there. At the same time, the Melbourne Age is talking about progressive enclaves in Melbourne, in Greens, Melbourne, facing the same issue. I asked myself why, what was linking these areas? I also realized too that I've been a teacher for almost 20 years. And when I talk about policies messing with parents in schools, they also affect us and the jobs that we must do. As we've just seen in the annual theater, that is the release of NAPLAN grades. It touches me, yes.
Thank you, Chidozie. Our next presenter is Gia Dat Phan from the School of Civil, Environmental and Mining Engineering with a presentation entitled Predicting and Preventing Landslides.
Do you remember building sandcastle when you were young? We all know you can't build sandcastle with wrong mix of sand and water. With too much or too little water, suction forces holding grains of sand together will decrease the stability of sandcastle, causing it to collapse. In my research, we use sandcastle analogies for studying landslides. Landslides are very destructive to people and the environment. Did you know last year there were over 450 fatal landslides around the world, where over 4,000 people died, resulting in extreme financial, environmental, and social damage to affected areas. So what causes landslides? Studies show that landslides are mainly caused by heavy rain and drought, as the amount of water in the soil affects the stability of the land. Today, we have computer software that is only able to predict when soil structure will collapse. However, what is often overlooked is how soil behaves differently in wet and dry conditions. Without this knowledge, structures are often over-engineered, wasting thousands of dollars in cost of construction, or under-engineered, creating unsafe or dangerous environment. My research investigates land behavior by developing geotechnical models, and my models will provide better understanding of the land behavior to prevent landslides. I use numerical formulas to model how wet and dry conditions affect suction forces in the soil. This is important because suction forces hold soil together. I compare my models with experimental data for accuracies, and my early results have been promising. This means we could potentially have software which allow us to model real-life soil conditions to better understand land behavior before construction. My study will provide greater confidence in designing soil structures, helping to prevent potential disaster, reduce cost of construction, and protect lives for greater society. Thank you.
Thank you for that presentation. Just in terms of understanding from an outsider's view, how often is water the major determinant of a landslide, and how often are other factors included as well? Is it the primary cause every time, or are there other factors that can also influence the landslides as well?
Sorry, can you repeat again the question?
So is water the only determinant of landslides, or are there other factors?
Yeah, I got it. Thank you so much. Good question. In this case, landslide is just one case of the soil collapse. In my study, I just developed a general models, and this model can apply for every kind of problem of the soil, including the foundation collapse, landslide collapse, or dam collapse, everything. Thank you so much.
Thank you, Gia. Our next presenter is Emily Skelly from the School of Biological Sciences with a presentation entitled Past Mouth Microbes for Present Mouth Maladies.
More than 90% of all people on this planet suffer from tooth decay. Every year, we go to the dentist, who drills, fills, and bills, and still our teeth rot. Because despite our shared disease status, despite more than 100 years of research, and despite the many advances in modern dental hygiene, we still do not have a cure for tooth decay. Now, living inside your mouth is a whole ecosystem of microorganisms. This ecosystem protects us from invading pathogens. And individually, these microbes play functionally important roles in keeping both our mouth and our body healthy. But if you disturb this ecosystem, you will cause disease, such as rotting teeth. So in order to address a cure for a disease, such as tooth decay, we need to understand this present ecosystem as a whole. But as Carl Sagan once said, you have to know the past to understand the present. So I'm going back to the past, using the power of ancient DNA and advanced DNA sequencing technology. My research looks to compute, characterize, and comprehend the many microorganisms that once lived inside the mouths of ancient humans. This way, I can directly answer questions like, what did this ecosystem look like before the industrialization of refined sugars? Or what did this ecosystem look like before globalization moved people, plants, and animals around the globe? Because understanding both the societal and the environmental influences on our microbial ecosystem will give us a better understanding of how we can manipulate this ecosystem for human health. Already, I have found that ancient humans had a far more diverse oral ecosystem than modern populations today. Species that we can rarely find today can be seen dominating in ecosystems of the past. And prior to the Industrial Revolution, only 200 years ago, most populations around the globe each had their own unique microbial community. Perhaps the reason we're not winning this battle against tooth decay is because we're clinically treating all mouths the same. My research is showing us we need to recognize the various ways that different ecosystems will respond to a disturbance. I am building the foundation for a cure for tooth decay. Thank you.
Thank you, Emily. I'm just curious, are there particular things that you think have changed the composition of the microflora over time, particular interventions, or do you think it's just a mix of everything?
I do think the Industrial Revolution had a huge impact on our oral microbial communities today compared to what they were perhaps in the past. But we're still trying to elucidate which one of those factors, or was it the combination of all these factors, that has made the changes that we see. Thank you.
Thank you, Emily. Our next presenter is Konstantin Seidel from the Center for Global Food and Resources with a presentation entitled Drought is Here. Are water users ready?
I love a sunburned country, a land of droughts and flooding rains. We've heard that before, haven't we? It's a passage from the poem My Country by Dorothea Mackellar. It describes the very essence of Australia, climate extremes and unforgiving droughts. It also describes the essence of Australian agriculture. I focus on the Murray-Darling Basin, a region staging Australia's mightiest rivers, but also its most devastating droughts. During the last drought in the basin, the Millennium Drought, there was only 33% of water normally available. And farmers adapted by buying and selling water on a water market. Let's call our farmer Joe. Joe bought water off his neighbor and maintained production, and his neighbor had an income despite not growing anything. The water market has since changed, however, attracting other water users, such as Jack, who's the director of an environmental organization, and also Jill, who's the manager of a financial investment company. Can Joe adapt to drought in the same way, now that Jack and Jill are in the market? I analyzed a survey of 1,000 Joes to understand how they manage future drought risk, with the water market as the most important tool. If Joe has a successor in place, he's more actively managing his future drought risk because he wants to hand down a healthy and resilient farm. So why did Jack and Jill enter the water market? Do they use the market differently to manage their drought risk? We simply don't know. So I sat down with over 50 Jack and Jills, representing the biggest water users, and I asked them, why did you enter the water market? How do you manage your drought risk? Jack owns water because it lets him help the environment independently of the government. Jill owns water for its unique risk characteristics and advantages as a long-term investment. Results show that while Joe, Jack, and Jill know about the risk of future drought, they do not manage it. I want to understand why they don't. This way, I hope I will be able to provide advice on how to motivate them to manage their drought risk. I can also help Joe, Jack, and Jill to understand each other better and how to manage their drought risk better. Are water users ready? Open the newspaper. Drought is here. Thank you.
Thank you, Konstantin. That was terrific. The 50-odd people that you engaged in interviewing, how representative are they of the total Murray-Darling context?
So I did it in that sense. I targeted my interview participants. So I looked at the CEO and managerial level of companies and water owners who have very high level of capital, water holdings, or sophistication. So in that sense, they're not representative of the basin population, but rather like the top 5% of the companies, like the big agricultural investment companies, the big superannuation funds. That's the type of people I was targeting, because the idea was you need a certain amount of capital and expertise to do a proper management of that resource. So I wouldn't expect mom and dad farmer to be amazingly sophisticated because they just don't have the money all the time.
Thank you, Konstantin. Our final presenter is Bernard Evans from the Adelaide Medical School with a presentation entitled What Dragonflies Can Teach Us About Motion Adaptation.
Imagine that you are in your car and you're driving down the highway at 110 k's an hour. You're on your way to Melbourne and you come to a town that you've never even heard of. And the sign says 60, so you slow down. But this isn't 60. This is 30, 20. Oh, I could get out and walk at this speed. We've all been here. It's a real phenomenon. It's called motion adaptation. And it allows us to detect changes in speed, whether we're moving very quickly or very slowly. Now I want you to imagine that you're no longer in your car, that you're this little dragonfly, and you're hovering down by the side of the river, looking for food and checking out ladies, when, out of the corner of your eye, you see a blurrish-looking blur, and you realize that it isn't food, and it isn't a lady, it's another guy, and he wants your spot. So what do? You dive down to get underneath him, but he dives down to get underneath you, and now you're stuck in this death battle where you're ducking and weaving and spinning and bobbing, and grab him by the tail, body slam him into the river, get back to your spot, and start checking out ladies again. All of this has happened in less than a second, and during this time you'll have pulled a 5G turn at 40 k's an hour. You'll have spun 1,000 degrees in less than a second. You'll have done this despite the fact that your brain is no larger than a grain of rice. But that's not the real problem. The real problem is when you build a speedometer out of brain cells, you need to pick a speed at which it works well. For humans, it's not a problem. Our brains are big, and so we can have as many speedometers as we like. But for insects, their brains are small, and they can only really pick one. If you like to hover in place, you pick a slow speed. If you like to zip from place to place or engage in death battles, you pick a fast speed. What about our dragonfly? He likes to do both. How does he cope? By playing videos to dragonflies in a miniature dragonfly cinema and recording the electrical impulses from individual brain cells in the dragonfly's brain, I have discovered the answer. It's motion adaptation. Dragonflies use it slightly differently from us. They use it to tune their speedometers, allowing them to wind them up or drag them down to slower speeds, without replicating any hardware. In essence, they get 3 speedometers for the price of 1. Now, I know what you're thinking. You're thinking, I'm not a dragonfly. Why do I care about this? Well, it turns out algorithms based on dragonfly vision are incredibly fast. And in 5 years' time, we are going to have drones flying around our skies and driverless cars driving around our roads, at least hopefully. And if these machines are to be reliable and safe, the people building them will be looking for solutions to problems such as navigation, object detection, and collision avoidance. The thing is, solutions to these problems already exist. You just need to know where to look, or perhaps the right question to ask, like, I wonder, how can this little dragonfly see? Thank you.
Do you have a question, dear judges?
That was fantastic. Again, this is going to be hard. Dragonflies, do you...
How on earth do you measure a dragonfly? How do you put a sensor on a dragonfly without it and measure cells without it actually impacting on the motion and the way the dragonfly operates?
Okay, so what we do is we get a glass tube, which we call an electrode, and we use a special combination of heat to pull it out, so it's very, very sharp at the tip, right? The tip is so sharp that you can't actually see it. It's smaller than the smallest wavelength of visible light. It's literally invisible, 100 times thinner than a human hair. And then we fill it with some goo and a little bit of metal, and we record the electrical signal, and we basically play lucky dip looking inside the dragonfly's brain. It's a bit more complicated than that. After 3 years of training, you can eventually be good at lucky dip. But it is still lucky dip. There are many experiments where you're just like, oh, that's it, I just want to go home. So what we do then is we have this cinema set up where basically we have a screen in front of it, and we can play to it whatever we want to see, whether it's images of natural scenes or whether it's more classical stimuli like bars and dots and so forth, so that we can basically pull out from the sound of the electrical stimulus that comes out of this individual neuron, because neurons create these little electrical impulses, and you can hear them, they make a sort of brrr sound, like a little buzzing. Right? So we listen and we say, okay, yeah, I think I've got the right neuron. No, I don't. That's a different neuron. Put something else up on the screen, see what it responds to. Oh, wait, it's going left, right. That's the one I want. And then we do our series of experiments and pull out these electrical signals, and these electrical signals correlate with things that the dragonfly sees. And that's how the whole process of recording from a dragonfly brain works.
Thank you, Bernhardt. Now, a big thank you to all our presenters. I think they did a fantastic job showcasing cultural diversity and the huge variety of research Uni Adelaide has to offer. I thoroughly enjoyed every single presentation, and I'm pretty sure it will be very difficult to select the winners. Now, it's on the audience to vote for the People's Choice Award. You should all have a ballot paper and pen by now. If you don't, please raise your hand, and one of our assistants will bring one to you. For your convenience, we put up the judging criteria on the screen again. So please place your votes by selecting the box next to your favorite presenter and wait for a volunteer to collect it from you. Meanwhile, we will have a short break to give our judges time to deliberate. During this time, we'd like to share some videos featuring previous 3-minute thesis winners. You might even see a familiar face. Please
so
enjoy.
Our 9th presenter, finalist from the Faculty of Science, Gemma Sifang. Finalist from the Faculty of Science, Gemma Sifang.
There are 2 types of jobs if you're a pig in the pig industry. You can be the bacon or you can make the bacon. In order to make the pork industry sustainable and efficient, we need to pick the right pig for the right job at the right time. And we don't always get this right. I work with the girls who make the bacon in the breeding herd. To get a job interview with me, you'll have to be a pig and you're going to need a uterus. That's literally it. Who I hire from there is pretty much random. And not all girls are cut out for this line of work. You're going to have to get pregnant young and often, which some girls are great at, but other girls just can't perform. If you can't perform in this job, you'll end up sent to market late. It's not good for the pig, and it's not good for the pork industry. In my PhD, we wanted to know why girls who have similar genetics and the same living conditions could end up with 2 different outcomes in the same job, and how we can improve this hiring process. I'm now going to tell you the story of the 2 girls on the screen. So these girls, their mums are pregnant at the same time, and so they share everything, a birthday, a home, and they got jobs together in the breeding herd. One of them ended up Employee of the Month, but the other girl ended up dead. So how come only one girl was able to excel in their field? Let's go back to the beginning. Not to the day they were born, but to a time just after they were a twinkle in their father's eye, during their fetal development. The girl at the top came from a litter of mainly males. So when she was developing, she was exposed to really high levels of stinky testosterone, so she was masculinized. Whereas the other girl came from a litter of mainly females. When it comes time for work after puberty, the girl at the top comes strolling in late if she bothers coming in at all. Her productivity is as low as her circulating estrogen, and she's not doing anything or anyone. Whereas the girl at the bottom, she comes in early, her hormones are skyrocketing, and she is getting it done. She's giving 16 and pregnant a run for their money. So when it comes time for their performance review at the end, which is actually just a pregnancy test, the girl down the bottom got herself knocked up. Great job. Whereas the girl at the top, she didn't even get pregnant. That's literally all she had to do. That is her full-time job. All she's given us is attitude, so it's off to the abattoir and off with her head. She's way past her prime, so we can't even use her for bacon. All we're going to get out of her is a few sneaky snags. And this has been my PhD. We started at the end with 2 very different types of females and worked out that females from a male biased litter are masculinized, and therefore they have lower hormones around ovulation and are less suited to the breeding herd. This means that my new hiring regime is going to be all about girl power, hiring females from female biased litters into the breeding herd. Thank you.
Thank you. Great presentation. And very engaging. Is there any free bacon, by the way?
No.
So how much bias does there have to be in order to exclude a female, and what percentage of the herd would exhibit that extent of bias? And
That's
so
a great
how much
question.
a difference can it make?
Yeah. So we started looking at a 70% bias, so 70% males as our male biased, because this is what was found in other litter-bearing species to cause a difference. But when we actually conducted the research, we found 60% was enough to cause a difference. That being said, in a normal herd, you'd probably get around 60% of your breeding females will have a 50-50 litter,
And that other 40% will be somewhere between 60% male biased or 60% female biased. But when it gets to about 90% bias, not many animals are having a skew that high, but 60% is fairly common.
Thank you, Gia.
Through high school and university, what I always wanted to work on was sustainable energy and like how we can help society move away from burning fossil fuels, getting out the sources of energy from sustainable means. The opportunity to work at Tesla in a role that's specifically working on the design and engineering of like new products to push this technology forward is like basically my dream job. The main point there is like just exposing yourself to as many diverse situations as you possibly can. So for example, for me that was working in Singapore for a consulting company, so in another country, in another culture, doing engineering work experience, and then also working in bars and restaurants throughout my degree, like in hospitality, where you are in fast-paced physical environments, dealing with customers, teammates, management, then having to study in France, where I was the odd one out because I couldn't speak the language as well as everyone else, but I was still taking like really challenging science courses at the time and trying to navigate that. So throwing yourself into situations that actively make you uncomfortable and push your boundaries, it's almost about getting comfortable with being uncomfortable. And the more times you do it, the better you get at adapting to new situations and being flexible. At Tesla, that's been extremely useful because it's a very fast-paced company that's taking on a lot of risk and is doing some really new stuff to try and solve problems, and there's a lot of uncertainty and challenges that come with that. And so you often do find yourself in, I guess, confronting or challenging situations, but I think that having been through those experiences before, and it makes me a lot more capable to stay calm and approach those challenges in a rational way.
So our first presenter is Frances Williams from the School of Chemical Engineering, and her topic is sustainable water treatment in developing countries. Frances.
We cannot survive without water. This is very easy to forget when clean water comes out of every tap. But for 336 million people, about 30 times the population of Australia, this is not the case. And contaminated water directly contributes to the deaths of 1,000 children every day. That's children under 5 years old. Chlorine is very efficient at killing bacteria, but there are many regions, especially in the tropics and the subtropics, where it's underused, misused, or too expensive. Moringa oleifera is a tree that grows in these regions. Its seeds contain a small protein that kills bacteria and clarifies cloudy water. The seeds are cheap, plentiful, and already used in local foods and traditional medicines. The seed powder kills a range of bacteria, including cholera and typhoid, and is already used in water treatment in rural Sudan. Preparing the seeds is a labour-intensive process, and the seed particles cannot be reused. And they quickly break down, leaving an unpleasant taste to the water. My research has focused on isolating the moringa protein and attaching it to sand, which is commonly used to filter solids from drinking water. This moringa functionalized sand not only filters solids, but also attracts and kills bacteria as the water passes through. This attachment prevents any further attachment of bacteria. So the second part of my research was to develop a method of removing this dead bacteria without separating the protein from the sand. Like with most things, the simplest solutions are often the best. When my sand becomes dirty, I wash it with a detergent. This causes the bacteria to separate from the protein. And if the detergent is non-ionic, uncharged, the protein stays attached to the sand. The detergent I'm using is fully biodegradable, making this a sustainable and eco-conscious method of water treatment. It's a simple solution to a significant problem because it means somebody with access to sand, moringa seeds, and water can actively purify their own water supply. Sorry, and detergent, I should say, not water. It can be used on any scale by a farmer in a remote village, or here in Adelaide, by you. It can even be retrofitted to existing sand filters, like those used during the last stages of wastewater treatment, before the water is released to the environment. With some more tests and large-scale studies, my research is the first step towards a new way of treating water for the world. Thank you.
Thank you very much, Frances. I think we may have a question from one of our judges.
Thank you, Frances. The question is around where you see your research going long term. Would you envision seeing new markets for the natural products, or would you see an industry that would look at synthetic molecules that you would take forward?
Well, very good question. It could be used for both. There's quite a big area of need in the developing world, in the countries I mentioned, which could just use the seeds from the tree. However, a very interesting article was published a while ago from a group in Switzerland who can produce this protein using E. coli. So that actually removes the need to use the tree at all, and means that, you know, us in a lab here, we could be producing this protein, attaching it to sand or something similar to sand, and using that maybe to reduce the load of chlorine in water, or to replace other kind of water treatment mechanisms.
I think working in the chocolate industry is a dream for most people. If I meet someone new and they're like, oh, what do you do? And I say, I'm project engineer for Hague's. They're like, wow, you actually make the chocolate. My job is 100% about problem solving. It's odd to be a graduate and to be the go-to person to fix a problem. A lot of people try and fit themselves into a mold or fit what they think they should be. But it's all about what are your strengths as an individual. It's incredibly important for graduates to be adaptable and flexible. You will not always be in exactly the same career. Why would you want to be? But university teaches you transferable skills that can be applied throughout different careers.
So now we're up to our fifth presenter, Katerina Richter, who is from the School of Medicine, and her topic is Bug Wars, Battlefront Biofilms. Thank you, Katerina.
Thank you. Let me ask you a question. When was the last time you took antibiotics? Did they work? I'm sure you've all heard about the rise of the superbugs, meaning more and more bacteria like golden staph become resistant to antibiotics. It is predicted that in the near future, 10 million people will die each year due to antibiotic resistance, which is more than people dying from cancer and diabetes combined. The stormtroopers of life-threatening diseases are fighting against our most powerful weapons. It's a battle against bacteria, and every one of us has to face this fight. One reason why bacteria become resistant is they live in biofilms. Biofilms are clusters of bacteria embedded in a self-produced slime, as you can see in the left picture. Biofilms act like an armor to protect bacteria from the immune system and to survive medical treatments. On top of that, bacteria in biofilms easily become resistant to antibiotics, hence our best medicine does not work anymore. Due to the spread of antibiotic resistance, millions of people suffer and die from devastating and recurring biofilm infections like non-healing wounds or life-threatening lung and heart diseases. Novel treatments are urgently needed and research has to strike back. Resistance isn't futile. We just need to know our enemy better. I identified bacterial nutrient pathways as targets, which are essential for bacterial growth and disease. Based on this observation, I used established biofilm models to investigate the anti-biofilm activity of two compounds that are not antibiotics. The first compound depletes nutrients from bacteria, making them hungry, grumpy, and vulnerable, while the second compound kills them. My studies showed no toxicity and significant anti-biofilm activity of my novel treatment against golden staph. 99.9% of biofilm was killed after treatment exposure, exceeding the antibiotic with 94% biofilm killing. Based on these promising results, I'm currently optimizing the treatment for the first clinical trial in Adelaide. The two compounds will be delivered in a wound-healing gel that is locally applied at the site of infection. This will complement the gel's wound-healing properties with anti-biofilm activity, reduce side effects, and fight biofilms efficiently. I hope that my research will give us new power to fight the dark side of biofilms. May the force be with us.
It's fantastic and very important work, Amy. Could you tell us what the your compounds that you're using to fight the biofilm, do they survive if you take them orally, for example? Do they get across the gut? So what's the scope of applicability? Is it just on surface type applications, or can they get across biological membranes so that they could work systemically?
Yeah, very good question. We use those two compounds directly at the site of infection, so the local application is very crucial for that. They won't survive the gastrointestinal tract, so they would be destroyed if they enter the stomach because of enzymes and acidic conditions, so they wouldn't cause any help over there. But if we apply those compounds directly where the infection is, that means where it's supposed to go, the treatment will be much, much more efficient. Plus, we don't have a systemic effect, so we don't have any kind of side effects throughout the entire body. And we increase the concentration of the compounds directly where they are needed. So hopefully it's working out.
It's really about discovering the passion more than anything for me, and the enjoyment that comes with learning, because it's just, it never stops in architecture. You can never know everything about construction. You can never know everything about design. It's just, design is subjective. There's no right or wrong answer. And the technology is shaping architecture too, so it's a constantly evolving landscape that you need to keep up with. I suppose at university, your tutors and your lecturers are there to help you and to guide you. They're not there to spell it out to you and make you memorise facts and figures. The architecture school is not a big school, so you know everyone in your class. Everyone's quite sort of tight-knit. There's a real camaraderie and sort of spirit as far as pushing each other on and producing better work. Sort of getting that breakthrough into the industry and getting your start, there is some luck involved potentially, but it's about sort of being confident and forming those relationships. And for me, some of those relationships started in the classroom at the architecture school. Yeah, the architecture school is unique in that a lot of the teachers are practicing architects who spend most of their time actually in the field designing, and kind enough to come in and share their knowledge and encourage the next generation.
Oh, now you all saw me in my red dress. I actually particularly wore it tonight. But trust me, I have more dresses than that. People were wondering. Right, so I have the results of the votes. And I would like to invite all our contestants to the stage. First, we would like to congratulate all the finalists for their amazing presentations, and they are now about to receive a little gift from John Williams. So just to recap, our 10 finalists were Veronica Coram, Joseph Rossi, Aditi Roy, Sarah Burnett, Caitlin Gray, Chidozie Alozie, Gia Dat Phan, Emily Skelly, Konstantin Seidel, and Bernhardt Evans. Now, for the ThinkLab Award, the winner is Chidozie Alozie. Woohoo! Congratulations. The People's Choice Award goes to Bernhardt Evans. And the University of Adelaide 2018 3-minute thesis winner, award goes to, again, Bernhardt Evans. Now, congratulations once again to not only to the winners, but to all our finalists. You all did a great job, and you can be very, very proud of yourself. Yeah. Also, thank you to everybody over here for being a special part of tonight's event. Don't forget, the Research Tuesdays resumes as per normal next month, so please check the Research Tuesdays website for more information. And that's it for tonight. Thank you very much, and good night.